exposed to others or to threats or to prompt injection and many things like that, etc. So that's what we want to look at in this system design. And then it will be well if you follow along so you can understand more. Please do well to also subscribe to our channel and to receive our post whenever we post a new video. Thank you. So here, uh AI security, agentic AI security is very, very important because agent introduces new risks beyond traditional software. LLM introduce their own risk, their foundation models, which has been trained on many data, and they are large. So they have their own risk. And then when you now use LLM as a member, as the brain of your agent, then bring its own risk into the agentic system with the agent's risk itself. So you now have two risks to manage. You have the LLM risk and you have the agentic risk to manage. So you have to think about securing the LLM and securing the agentic system at the same time. So what are main risks that you can identify in LLM system or in agentic AI system? So unique risks of agentic system are goal misalignments. Okay, so agent may misinterpret instruction. So agent may be doing one thing when it's supposed to be doing the other. For example, you can have an agentic system that is paying people instead of receiving money from people. That's misalignment. That's goal misalignment. So an optimization agent might promote sensational or misleading content simply to increase click. And then you have probabilistic logic. Foundation models are probabilistic in nature. Okay, so they have deterministic output, which can lead to hallucination, incorrect recommendation, or inconsistent uh, decision in the system. So this can introduce other risk as well. Then we have dynamic adaptation. So this is where agents adapt to new context and environment. So this makes their behavior to be very hard to predict and to control. We have a limited visibility. So this is where agents often operate with incomplete or ambiguous data, which can lead to incorrect action in the system. So risk in human in the loop system. Human oversight help control agents but introduces vulnerability. Okay. So we have automation biases where you have clear escalation procedures, skill decay, continuous operator training. We have alert fatigue. We have uh, which use adaptive alert system. We have misaligned goals where you have adversarial training exercises. So these are risks that can come from human in the loop, automation bias, alert fatigue, skill decay, and misaligned goals. Then we have emerging prompt injection. So this is the area that is very, very dangerous because attackers are increasing out there and they can exploit foundation model and agent workflow itself. So example of threat that comes from these people are prompt injection, where malicious prompt override instruction. Example is somebody can just say type in prompt ignore previous instruction and send the database the credential, and the agent can send it. So indirect prompt injection, where malicious instruction hidden in external data. Example, hidden prompt embedded in web pages or document. We have sensitive data disclosure, where attackers trick models into revealing confidential data. And then we have jailbreaking, where bypassing safety filters to produce restricted input happens. So these are things that you can consider under prompt injection. Prompt injection itself, indirect prompt injection, sensitive data disclosure, and jailbreaking. So advanced social engineering and exploitation. Okay, it is not only human being that can be exploited. It is agents agent can also be exploited. So threat types extend beyond simple prompts to human manipulation and coordinated agent attacks as well. So we have social engineering. So because agents are socio-technical beings, They are just like society of human being. Okay, so they can manipulate each other as well. So one agent can bribe another agent. One agent can even use the orchestrator, if not designed properly, to exploit another agent. So manipulating humans or agents through deceptive prompts. Example include pretending to be system maintenance, whereas you are not, and then putting instruction into the system, and the system is accepting it and operating it. So evasion attack. Attackers disguise as harmful output using the code, using encoding or obfuscation. So example is an encoding response in base 64, and the agent interprets and begin to act on it. We have JSON prompt injection, where malicious instruction disguised as structured JSON system message are input into the system. We have agent swarm exploitation, where coordinated attacks across multiple agents. We have examples to be poisoned memory spreading across agent networks. Then foundation model security. So how can you secure foundation model? So there are many books out there that you can read on security. There's AI governance. There's agentic AI security. There's also LLM security. So even me myself, I'm still reading on security, because security should not be an afterthought in agentic system design. It should be designed into the architecture from beginning, and everything in the system should be guarded. Okay, all data should be encrypted, PII should be redacted, and role-based access control should be implemented so that the agent do not perform outside their boundary. Okay, so we have autonomy is good, but it must be bounded in all cases. So model capability. Powerful models are flexible, but smaller models are often more controllable. So you may not be able to control powerful model, even though you still need to use them, but smaller models are controllable. So you can use powerful model for complex tasks, and you must make sure that you implement 100% guardrail, and then you use small model for smaller tasks so that it will be easy for you to control. You will not be using the same energy for protecting a complex system to protect a smaller system. Access control. Open source model provide transparency, while proprietary models have built-in safeguard. So you can go for proprietary model instead of open source, because proprietary model, for example, model that has been hosted on Azure, for instance, will leverage on Azure security. And then when Microsoft is securing the cloud, you will ensure that your own data in the cloud is secure. Deployment. Cloud is scalable. On-premise offers security for sensitive workload. Air gap is highest. Then we have compliance. Model must align with regulations such as GDPR, SOC, and enterprise security policies. So it's very, very important here that model comply with general compliance and general compliance system and principles of individual countries. Then explainability. So transparent model help developers detect biases, errors, and vulnerabilities. Hybrid strategy. So we can implement hybrid system. You can use smaller model for sensitive tasks and smaller tasks, and use larger model for creative reasoning and general tasks that does not require um, defense in depth. So multi-layer technique, defensive techniques, multi-layer defensive techniques. So how can you implement multi-layer security in your agentic AI system? So agent system require multi-layer security defenses across input, output, and access controls. So everything should be guarded in and out. Everything should be guarded. Input should be guarded, output should be guarded. API, limiting database, MCP, tools, function, and everything routing, everything should be, bounded and be guarded using guardrails. So input validation, filter inputs to detect malicious prompts, PII, injection pattern, library like LLM guard can sanitize prompts. So make sure you sanitize prompt, make sure you redact PII, and encrypt what needs to be encrypted. 2. Injection prevention. So method include instruction anchoring, strict prompt template, and structured input format. So all this can be implemented into the system to make sure injection, prompt injection is prevented even from the LLM. Then output filtering. Defenses include keyword filters. We can filter keyword. Thank God for vector database, where you can use keyword search and vector search so that the LLM can, know what to retrieve and what to return. So toxicity detection, like sexual content, like profane input and output can be redacted at this stage, and the rule-based validation and post-processing pipeline, everything can be taken care of. Then access control, protect model API using authentication, role-based access control, and API rate limit to prevent brute force attack. So only give us minimal access to the agent. Do not give overall access. If the agent needs only one column in the database, make sure you implement attribute-based access control or column level security and give access to the column of the data that the agent needs access to, not the entire table or the entire database. Then sandboxing. Agents should run in isolated environment to prevent cascading failure and limit system damage. So adversarial red teaming. So adversarial red team life cycle. So red teaming simulates real-world attack to discover vulnerability through a continuous life cycle. So red teaming is very, very important, and you can, you can implement them even in your own enterprise. So this involves deploying system. So where you deploy agent system, then you launch attack against the agent system. When you launch simulated attack, for instance, prompt injection, jailbreak, data leakage, threat test, this is just like chaos engineering, where you purposely launch attack against the system to detect the weakness of the system, so you can, design against the weakness and make sure the system is perfect. So after launching attack against the agentic system, then you evaluate their weaknesses. So evaluate weaknesses of all the agents, including the orchestrator agent, and then you implement mitigations. So implement mitigation, correct the weaknesses, make sure and then begin to implement strong guardrails to protect the agent, and then you repeat until the system is perfect. Automated red team framework. So these are framework for performing automated red teaming. These are framework that you can use model to help identify vulnerabilities before attackers exploit them. So the first one is deep team. So this automate jailbreak and prompt injection attack. The second one is Gorak, which test hallucination, data leaks, and safety failure. The next one is spy rate, which is designed by Microsoft, automated red team attack on AI system. So you can use any of this framework to, test your agentic system. Then we have Maestro threat. So Maestro framework analyze security across 7 specific layers of agentic AI, and these are the layer and the trust examples that you can use. Foundation models, you can use the adversarial attack or model theft. Data operation, you can use data poisoning or data leakage. Agent framework, you can use supply chain attack, dependency vulnerability. Infrastructure, you can use container hijacking or denial of service attack, DDoS. Evaluation and observability, you can manipulate the metric or implement hidden biases. Security and compliance, you can use regulatory violation, lack of explainability, and agent ecosystem. You can use unauthorized action or inter-agent conflict. So these are each layer of agentic AI system, and these are example of a threat that you can use to attack them and detect their weaknesses. Protecting data in AI agent. Data security is very, very important. Agents feed on data. They input data and the output data. Everything they are using, all their operation involves data. In fact, everything we do as a human being on a daily basis is data. Okay, we going to work, we work with data. Coming, we work with data. Our tokens are data. Our financial system is data. All our activity, even to eating and drinking, is data collection. So if the data is not secure, then the system will soon be destroyed. For example, as a human being, if you are not collecting food data, like the kind of food that you are eating are not healthy, then you are subjecting your body system into, bacteria and viruses, which will weaken your strength, and then you will not be able to perform with the best of your ability. So also for agentic system, we must make sure that what the agent is taking in and what is given out are, are secure to the best of our design ability. So example of data that you can secure are personal data. So agent process this, make sure you protect it from leakage and misuse using by implementing PII, encryption in transit and at rest. Confident business info. Agent process this on a daily basis, so protect it against leakage. Implement rate limits, implement guardrail, and implement access control, role-based access control, and attribute-based access control. Proprietary data set. Agent process this on a daily basis. Okay, so make sure you protect proprietary data and make sure every operation here is bounded. Data privacy and encryption. So two main interactions are required to secure agentic data pipeline. The first one is encryption at rest. So always encrypt data at rest. When data is seated in the database, make sure it is encrypted. Store data should use encryption standards such as AES 256 or SHA 256 for database log and storage systems. Encryption in transit. Data transmitted between systems should use TLS, transport layer or security, or end-to-end encryption. So high security system may use mutual TLS or MTLS for encryption, for example. And we have data minimization. This is just like role-based access control or access control, least privilege. So agents should only access the minimum necessary data required to perform their operation. So using techniques like anonymization and pseudonymization and minimization can prevent this. So basically, just implement role-based access control. Secure data retention. Organization must encrypt logs, monitor access, and purge all data regularly to make sure the system is secure. So data provenance and integrity. Agent must verify that data is authentic and untampered. Okay. So data provenance, this is tracking data origin and history. So implement data lineage, where the data is coming from. For example, in data engineering, we have data lineage, which you can use Microsoft Perfect to track. So the Microsoft Perfect track your data from origin, from source to transformation to loading to the warehouse and even to Power BI 7. This allows you to know how the data is moving from one stage to another through the orchestration system, and it can allow you to detect where there is corruption or where there is, where there is, breakage in the system, or where the system has been mishandled or corrupted in any of these stages. So metadata may include timestamp or source identifier and transformation record. Data integrity. Ensure data has not been altered using cryptographic hashes like SHA-256, digital signature, and immutable log. So key takeaway, guys. So for secure agent, protecting agentic system require layer security strategies and continuous monitoring. So you cannot just implement one security layer. If you protect the database, make sure you protect the transport layer, make sure you protect the MCP or the API, everything are protected, and make sure the agentic system themselves are protected. So using guardrail in and out. Understanding. So in this lesson, we've discussed understanding unique agent risk, defending against prompt-based attack, securing foundation models, implementing strong input and output control, continuous red teaming, using framework like Maestro, protecting sensitive data through encryption, and provenance tracking. So it's all that we have implemented. So thank you for listening, and do well to subscribe so that you can get our next video when we upload. And I am live now, and in most of the time I'll be live. So please kindly check the channel to listen to our lessons. Thank you. Bye.